Hello everyone, this is an overview on setting up basic character movement and combat system in Unreal Engine 4. I'm going to focus on setting up the anim graph. This is the first time I'm making a tutorial and this is very much a work in progress, but hopefully it'll help you out. So let's begin. This is the third person template and everything you see here you can get for free from either the marketplace or the content samples or the starter pack. And basically you want to grab the Mixamo animation pack, and we'll be using the Atom character along with the anim starter pack, and these animations have been retargeted for the Atom skeleton, and so basically this Atom guy can do everything that's in these animations. You might also want to grab the rifle mesh from the shooter demo. Basically go to the shooter demo, load it up in the editor, and then migrate it over. You want to use this migrate command and then select the content directory of the target project, this project. So that'll give you the mesh and the materials and the textures and everything, and you don't have to grab them one by one. So let's see what's going on here. If I start the project, you can see the Atom character is able to move around, and basically this guy has two modes of movement. You have normal mode and then you have combat mode. So let's see what happens in normal mode. Is if I face the camera forward and I press the forward key, the character starts moving forward. But if I press the backward key, the character will turn around and then move forward in his forward direction, but he's basically walking into the camera. And left and right is kind of the same. The character turns and walks in that direction. Also, the camera is free, so it's locked to the mouse. So if I can move full 360 degrees on the character, but I do have an upper and a lower lock, so I don't go too far in either of those directions. Plus, I can zoom in and zoom out a little bit. So I can basically, the mouse is free from the character's movement as well, so if I can move the mouse while he's walking and he'll adjust accordingly. The second mode is the combat mode. So basically the character will equip his weapon, and then if I press the forward key, he'll start walking forward, and if I press the backward key, he'll walk backwards. The character no longer turns around. And the left and right is similar. The character will no longer turn, and he'll keep aiming at the aim point, at the target point, and he'll just strafe left and right. And while still in combat mode, I can also crouch, and basically it's the same thing: forward, backwards, left and right. And you could also go diagonally, because there's a blend space operating on this. And you can go diagonally backwards too. One thing that you can also do, there's also a bit of an animation going from crouch to standing, and there's a montage that does the unequip and equip part. This character can also sprint, so this is sprinting as opposed to just walking, and then there's also jumping in the jump animations. So basically that's these are all the things that it can do. One last thing you might want to take note of is that in combat mode, the character can still sprint. So he's walking forward and then he's sprinting, and when he's sprinting, the aim point, the aim offset has been turned off, because otherwise the character will kind of twist and turn in all kinds of weird directions. Similarly, for crouching, you can move forward. If you start sprinting, this is a different sprint animation, and then when you stop sprinting, you go back into crouch mode. So we're going to do all of these things from the anim graph, and basically, some of the controls and some of the settings have to be set in the blueprint, but this particular tutorial is about the anim graph. So let's just load that up a little bit. So yeah, this is the blueprint, and we want the anim There we go. So anim graph, and we have two state machines, locomotion and weapon poses, and how we're going to blend between the two and use them we'll see in a minute. So basically we want to get here the final animation pose that gets shown on the screen. So how do we get here? Well, first, right off the bat, you'll check if you're in combat mode or if the weapon is equipped, and if it's not, then you don't need the weapon poses state machine. You just need locomotion, because locomotion controls the forward, backward, crouching, jumping, all of that. So yeah, let's just first see what is happening in these state machines. So like I said, there are only two of them, the locomotion state machine and the weapon poses state machine. This controls forward, backwards, movement, basically jumping, crouching, and this controls things you can do with the weapon, firing, reloading, firing while crouched, and all of those nodes. So let's just open this up and see what's going on in here. So there are two main nodes in this state machine. You have idle walk run, and then you have the combat version of idle walk run. This is basically a 1D blend space. 1D blend space that takes a speed input, and what it'll give you is basically you're idle, you're not doing anything, character's not doing anything, idle slowly. This is walking, and then this is sprinting, and from the blueprint event graph I can set the speed down a little bit to differentiate between running and sprinting. Well, that's how I implemented it. You don't have to do it that way. In the combat idle walk run, instead of 1D space, I used 2D blend space that works both direction and speed. And what this does is it allows me to basically to do a strafing from the blend space itself, as you've seen. As what I've shown you just a little bit ago. So other than yeah, this is the normal mode. So these nodes will be operating in normal mode, and these nodes will be operating in combat mode. In normal mode, jumping is done by a 3-point jump system, 3-node jump system. So the jump starts, and then the jump will go into this loop for as long as the character is in the air, and then when he finally hits the ground, it'll run this animation and then go back into idle walk run. And this is the way I'd recommend you do all jumps all the time, and you'll see why in a bit when I show you, because that's not how it's implemented in the combat portion of the state machine. In the combat portion, basically you jump and then you go back to idle walk run, and that has a negative side effect that I'll show you in a minute. Other than that, there are also animations going from the combat idle walk run to the crouch idle walk run, and these animations go from standing to crouching and from crouching to standing. And also, if the character is moving, then these animations are skipped, and there's also a direct transition rule. So these rules are really simple, and nothing too complicated over them, just simple checks whether if the character is jumping or it's supposed to crouch, or the crouch is ending, or so it's really nothing overly complicated here. There are two types of jumps: a jump from standing and a jump from when you're running, and then sprinting, and you can sprint from a jump. And I'll just show you how these work out in the end. In the normal combat, in the normal mode, you also have this jump when you're moving, and then this jump animation when you're standing still. So this is a simpler jump animation, and this is a 3-part jump animation, and I'll show you how these work again in a bit. So in the weapon poses state machine, you have an idle pose which basically doesn't do anything. It just it's idle iron sights, and so when the weapon is firing,
this node becomes activated because you see the Boolean weapon firing, and you set this in the event graph. So this transition rules will push it into this, and I'll start looping on this animation. You can see the character is firing his weapon. So it'll just keep firing as long as the fire button is pressed. When that is over, it'll go back here, and then immediately it'll get out, and you'll see how that happens. This node doesn't really get activated very often, or doesn't really contribute much. And in the locomotion state machine, majority of the time will be spent in this node or this node. These two blend spaces contribute much of the output from this state machine. Right, so in the final animation pose, the very first thing that will happen is, are you in combat mode, and is a weapon equipped? And if it's not, then if the weapon's not firing, or if there is no weapon, then there is simply no need for this state machine at all, right? So you just check with this node, blend poses by bool, if this is false, if there is no combat mode and there is no weapon, then you just need the locomotion state machine, and you don't need the weapon state machine. So all of this just gets ignored. It's not needed, and we just work with the locomotion state machine. And one thing you should know about these state machines is that the output from a state machine can only go into one input. So if I have this state machine and I want to connect it to over here, I could just drag this pin and connect it directly over there, but then I wouldn't be able to connect this state machine anywhere else, and these two state machines are used all over our animation graph multiple times. So the way to do that is to store the output from a state machine into a cache node, right? So you have a locomotion cache, and then you have a weapon pose cache, and basically whenever you see this node, just think locomotion state machine or the weapon poses state machine. So here we've connected the locomotion cache to this pin, which is basically the same thing as directly connecting the locomotion state machine to this pin. So yeah, that's what happens when there is no combat and there is no weapon. But what happens when there is a weapon and when we are in combat mode? Well, then things are a little bit more complicated. So let's just go into combat mode over here. Weapon is equipped. Now you are in combat mode, and we go back to the anim graph, and it's not updated, and that's why. Okay, so now you can see that both of these state machines are active and contributing something, and what that thing is we'll get to in a minute. Rather than showing you the nodes from this end, let's start at the other end. So this is the other extreme end of this anim graph, and you can see it's using directly locomotion cache and the weapons pose cache. This is basically the same thing as adding these two state machines directly to that mode. The locomotion cache and the weapons pose cache are directly the alternative names for these two state machines, right? So just think of these two state machines as directly connected to this node. Layered blend per bone. So what's happening here is this layered blend per bone is configured to apply from the spine upwards. So blend pose 0 will get applied from the spine upwards if blend weight 0 is 1. So at 1, it'll get applied 100% from the spine upward, and at 0, its contribution will be 0, and you will basically be looking at only the locomotion state machine's output, and the weapon poses state machine is just being completely ignored, and that's what's happening here. This blend pose weight is 0 right now, so all of this motion is just the locomotion state machine, and even though we are in combat mode, only the locomotion state machine is contributing anything. So let's see how we can change that a little bit. Let me see if I can just fit this on my screen. Right, so if I was to start firing, or if I was to reload the weapon, then you can see that the weapon's blend pose weight goes to 1, and I've set up the event graph to basically interpolate this value from 0 to 1. So when it is firing, the blueprint knows, and it interpolates this to 1, and this weapons pose cache or weapon state machines gets blended on top of the locomotion cache from the spine upward. So now I can move and fire, or I can move and reload at the same time, and it just works out this way. So the result of this blend is then stored in the weapons locomotion cache. Now you can name these nodes, and I didn't really do a very good job at naming them. I just took weapons and locomotion and just kind of glued them together. So, but you could probably pick better names for this. So what happens here is this result, I'm passing it into another layered blend per bone. Why I'm doing this is because, let's say there's a montage that I want to play on top of my existing state. So I take the result of this, and then I do another layered blend per bone again from the spine upward, but this time I apply a montage, and again I have a blend weight. So basically the montage I'm applying is the equip and unequip part. So it's walking and unequipped, weapons been unequipped, and that is being handled by that body slot, upper body slot, this bit. So the way you do this is you take this result, and basically this is the same result, weapons locomotion cache, same thing, right? Same thing. And if the weapon is currently being equipped or unequipped, this value is going to be 1, or it's going to be between 0 and 1. I interpolated it, and this montage will then get plastered on top of this result, and then this gives me the weapons locomotion equipment cache. Again, terrible name, but you get the idea what this is doing. So in the third step, I plaster an animation EAM offset on top of what I already had. So at this point, it can move, the character can move, fire while moving, equip his weapon, and do the same while moving, so he can equip and unequip while moving. So now I want the animation EAM offset. So again, blend poses by bool. Right, so sometimes when you are in combat mode, you don't want the animation EAM offset to be enabled. So you don't want this to be applied all the time. You only want this to be applied some of the time. And an example of this is basically when the character is in combat mode but starts sprinting, and then you don't want the animation EAM offset on at that point. So I'm using this node and this boolean, which I set from the event graph here, to basically turn this on and off. And if this is false, then this is the only result that I use. So basically this is the same node. And if this is off, then I only apply this result, which is basically this result, which is basically this result, which is basically the state machines. So here the animation EAM offset are basically these animations that I have made frame by frame. And so you've got left, right, center, up, down, and this node basically just takes a yaw and a pitch input, and it will allow you to basically do this. You see the character is not moving, but if I move the mouse around, he'll move his weapon and point it at the aim target. And I've also interpolated the whole thing, so if I do a sudden movement like this, the gun will kind of slowly move towards the target or the aim point. And if I go too far, the character will turn, and then the aim will be at 0 degrees. So it'll just move the upper portion of the body for a little bit, go too far, and the whole character moves. And that, but I guess that's more control from the blueprint than it is from the anim graph. So that's what this is doing. And again, this is the final result that gets decided by this first node, whether you are in combat mode or whether you are not in combat mode. And well, that's basically it. And the event graph, yeah, I guess this is another tutorial. This is getting a bit too long. We'll come back to this some other time. But I just wanted to talk a little bit about the animation graph and some of the things that I've done to make this character do all the things that he's doing. Well, that's it for this tutorial, and I hope I helped you in some way. Or if you have any questions, just drop me an email or leave me some comments. All right, thanks.